Hi, everybody. I'm Drishti. Thanks for the wonderful introduction. And so today we have been learning a lot about advanced features in Python, a lot into the core development. Why not add some fun to our conference learning experience? That's wherein I teach you how to build games in Python. So we are going to evolve from the dinosaur age to the current world in a step-by-step way through a bit of a code as well and some interesting features that you might want to add on to your game development. To kick off, let me tell you a little about myself. So I'm a software developer, now getting involved quite a lot into the machine learning space as well. I recently published my first technical book. It's a book on Laravel, the PHP framework. So I'm somebody who's pretty active into the Python space as well as the PHP space. I'm a social entrepreneur. So before coming to the States earlier last year, I was in India, worked full-time at top product-based companies, and also ran my own non-profit organization, which helped underprivileged children to learn tech skills so that they would have a much more stronger, brighter future ahead. And I'm an international tech speaker, having spoken at a ton of conferences across the globe, especially a lot of PyCons, sharing my knowledge and expertise with everybody in the community. And I'm a career coach. I have my own initiative called Skill Up with Drishti. This is something I set up to streamline the process of people who want to connect with me so that I have a calendar link and people can connect and discuss different things that they're looking into. And in the bottom, you'll see my Twitter handle. I'm pretty active there, so feel free to tweet about the talk, about your experience, or if you want to connect over some collaboration project, my DMs are open. Now coming to game development. Before I kick off the talk, how many of you have done some sort of game development? Can I see a raise of hands? Okay, I would say about 30–40% of the room have tried their hands on it. For others, we are going to embark on the interesting journey of games. I think everybody must have played a game sometime or the other in their lives, right? Anybody who hasn't played a game at all? No one, right? So games have been a part of our lives since we were little kids, right? From games which are not digital, like physical block games, to the current world wherein we even say on social media streaming platforms or streaming platforms like Netflix, they're adding in games because people have a little shorter attention span, and how do you keep your user engaged or hooked onto your app? That is also a good place wherein games are finding a lot of integration. So the core things about game development is that there are 4 things that you should take care of. One is collision detection. While building a game, you can divide your paper into 4 parts and write about what your game does in each of these 4 sections. This is my way of building a game. The first is collision detection. What happens if 2 characters or 2 objects in your game collide? If it is like a snake game or a caterpillar game, is it one object eating the other object and then some transformation happening on the first object? Or is it like a race car game, wherein 2 cars, if they collide, what happens next? So you need to find out or write down what do you want to do in that case. The second is rendering. How important is the graphical aspect of your game? Is it a simple 2D version or is it a 3D version? Or if you're building for a VR application, then you need to also think about depth and a whole different set of concepts. So rendering, how do your images look like? How does your complete game look like? That is what you do in your rendering part. The third is game loops. Just like we want to avoid infinite loops in our regular coding, in the same way, we need to avoid any kind of game loops that happen. Imagine if there is a car in a race car scenario, and if a user presses, say, the right key continuously, the car will make a donut, like it will go in circles around the space. But it should not be a scene wherein if the user leaves the key, the car is still going in those circles. You need to remove any kind of loop that even by mistake a user might do. And yes, follow physics so that it is intuitive and parallel to the way the normal world works. Things from the sky, if they fall, they should fall on the ground. This becomes only an exception if you are thinking of building an out-of-the-world game, say a game on Mars or a place wherein the basic concept is a no-gravity zone. Only in that case, you should not follow physics concepts. Otherwise, please make sure that you follow that. And this is wherein a lot of us leave the small mistakes which tend to give a bad user experience for different characters. So now that we know how different 4 things are the key concepts that we should take care of while building games, let's build a simple game. So This is the game that we are looking to build right now. It is like a simple caterpillar game. That's a caterpillar that's eating food. And it is very similar to the way the snake game used to be in like Nokia phones like 15, 20 years ago, or a simple phone. And the additional thing, if we decompose the way the game is working, the edges of your game, they are not hard constraints. The caterpillar can go from one part of the screen to the other and come out of it in the same pixel position. So you're talking about pixels and how that should happen. Top, bottom, right, left. Both the places, the object should be able to come from one place, go out the other, and that is the complete loop in order for the caterpillar to be able to make the most of it. So how do we do that? This might look to be like a very, for somebody who's not done any game development, this would look like a complex thing, because in this scenario, when my caterpillar touches the caterpillar part again, that is when the game should end. So that is the collision detection part. Physics that right to left converts into a loop again to right to left. It can't go from right and come from the top. So things like that. But actually, this is like less than 100 lines of code game. Let's see how do we build it. So the very first thing that I did is I set the width, height. The food size is the green square that you saw that the caterpillar eats. The delay is 100, and I've set some offsets as well for up, down, right, left. So basic, simple logic that you would think of for a game like this. The next thing that I do, this is the main function that I have, which is to move my caterpillar. How does my caterpillar move? So if you see, as soon as the caterpillar comes in contact with the square food, I'm duplicating the head of the caterpillar. That is one circle, I'm adding one more circle to it. So that is what I do. Then if you see that if it goes to caterpillar's end, that is my reset. That's when it resets. It can't eat itself. And in the other option, it is that I append the new head that is there. And I also see that if the food is eaten by the caterpillar, it should pop out at a different place. I can't have the food to be at the same place. And I do this in a very simple scenario of having my caterpillar move, setting the widths, the heights, based on my calculations. This is a very basic implementation. And you can see it is a very self-explanatory code as well. It is very intuitive when you think about different aspects of your game. The next part that you would want for a game is what happens when you call reset to it. So like the initial coordinates, the initial size of the caterpillar that I want, like the circles, and an initial food position that I want, which I'm taking as a random position of the food. And then I'll again call the move caterpillar function. What happens when it eats the food? That is like food collision. That is wherein I'm taking care of actually getting the distance of the caterpillar, appending it, and then going to the food position. These are individual ways of adding that circle one more time for the caterpillar. The next one is my get random food position. So that is again a random object, but in random as well, you want that food to be in your space of the 500 by 500 width height that is set. And then you return the random position of the food. Get distances, again similar to that. It is like root of y2 minus y1, x2 minus x1 square. So that is what I do in my get distance. And a few helper functions. So what happens when, I'll show you the final code which calls these functions, but what happens when you press the upper key on your keyboard? It should go up, then right, left, left, down, down. So that is what happens. And this is the final way you would call it. So this is wherein I'm using turtle. In turtle, you just set up your screen. The title is caterpillar. This title was something that was like visible here. You can see like it's called caterpillar, the screen that we see. And that is, also you can change the background. Now here, if I wanted to make it advanced, but in a simpler way, I would download a photo, probably of a garden or something wherein caterpillars are found, put that as the background instead of the white plain image. And then I would set up my screen, add a tracer, turtle, the caterpillar is made of circles. I could turn it to triangles based on my application and change that circle to triangle. My food is green and square, my food size, and then go up, go down, happens with screen on key. So my on key go up, go right, go down. These are inbuilt functions with Turtle that you can use directly on your screen. And then you would reset and call the done function. So if you see, building this game is pretty easy. If you see like my screenshot as well, I think, yeah, it's like less than 50 lines of code, because I've reached like the green square already. So it is a very small piece of code that can help you build a simple game like this. Now that we saw, and I hope all of us are no longer like feared of making games, that it is something very complex. Let's look at some advanced features of game development. So being a part of the Python community, it is important that we use the power of Python libraries that is there. So with game development, these 5 are the most used Python libraries. There are a ton of open source more libraries as well, which combine the best of a couple of libraries together as well. So I'm going to be focusing later on Pygame, but I want to also tell you why one library over the other, what are the pros, what are the cons of each. So with Pygame, there's a very, very active community. It is a very versatile community. So if you're somebody who's learning on your own, then having a good community plays a major role in you advancing and creating more complex games. So that is the benefit that comes with Pygame. The con is the limited 3D capabilities. So if you're looking at building like a 3D game, or even a game wherein, for example, something like Subway Surfers, wherein there's a path, your object moves on it, then it jumps across some other object, and you see it in 3D. So that is something which becomes a little complex with this. For that, there are a few mode libraries. If you use Panda 3D, this is what you should use if you want to build a 3D engine for your game. So this leverages Python scripting along with C++ for any performance-critical components that are there. As you might know, Unity is very widely used in the game development industry, which relies on the C++ interpreter compiler. And those capabilities plus Python's simplicity is what happens in Panda 3D. The only con is that it has a steeper learning curve. One complexity is because it is a 3D game engine library, plus the second is it does not have as strong as a community presence, I would say, as Pygame. Because not a lot of people develop in Panda 3D. So you might encounter issues which nobody else has actually encountered. So it might be difficult to get an answer, which generally is not the case with Pygame. The next is Arcade. The pro is that it has a built-in physics engine, so you can directly call in a lot of functions. You don't have to take care of the physics part of building a game, and you can directly use the functions if it is a simple game. And the only con is that it has a limited feature set for large-scale game projects. So if it is something like a like Fortnite or something which is like a multiplayer game, wherein you have multiple characters, multiple levels, multiple instances that can happen. In that case, Arcade might not be the best choice. Then you should go for Pygame or Panda 3D if it's a 3D game. The next is Pyglet. The pro is that it allows a low-level control for each of your characters. Plus, it is very lightweight. So if you're building something which has to be more efficient or which has to be more lightweight, then you should go for Pyglet. Especially if it is like a web app and you're say including a small game in that, then this is the best solution out there in the Python space. It has a little less documentation, but if, say, you have already built games in Pygame or Panda 3D, then it will be a very easy thing for you to go ahead with that. And the last but not the least is the Godot engine using Python scripting, that is if you do it. The pro is it is a lot of visual scripting. So you can build games without writing a lot of code. It makes it very easy for somebody who's new into coding itself. The con is performance consideration. So since you're using a lot of low-code, no-code objects, you'll have less possibility to tweak it based on your requirements. So that is the con that comes with it. Now let's look at Pygame. So Pygame is a Python library for game development. With Pygame, the benefits are endless. There's a huge community. I emphasize a lot on the community because in the current space across any software development that you're doing, including game development, the community helps you in adding in new features that's happening in the world into your games. Plus, you might find out great hints which you might have not thought of because you're doing it alone. But with the community, it's a sense of belonging. You get to learn from each other. You get a lot of new ideas and make your games more efficient. The core concepts with Pygame are initialization modules, the displays or surfaces, and images. I'll tackle each of these individually. The very first one being initialization and modules. So to initialize a Pygame, you use the .init function. It is required, and then you can run your game across Linux, Windows, as well as Mac. In order for modules, it is like the abstract part of each game. You create different modules which are abstract to each other, and it also helps you access specific hardware benefits that you have. If you have a GeForce chip, an NVIDIA chip, or any other specific gaming chip, so there are more capabilities that come with it. So why not make it more abstract, make a module specific for that, and then build your remaining game on that module? It makes it very easy. The second core concept with Pygame is the display and the surfaces. So there's a surface class, which is a rectangular area wherein you can draw. Draw in the sense wherein you build your actual game, your different characters, your, say, trees, boats, rivers, everything. The next is everything is viewed on a single user-created display, which can be either a small window, like a caterpillar window, or it can be a full screen. So if you have to remember out of this, so in Pygame, it has to be a surface class, a display, and if you want to create the display, that is creating using set_mode. That is the function. So once you import Pygame, all of these are inbuilt things. You just have to write it one by one, and you'll have a basic setup ready. And once you have the set mode, it returns the surface, which is the surface class object, and that represents the actual visible part of the window that is there. In game development, having a visible window part and a window is different. A visible part is what your user is seeing, but maybe on the back, you are rendering something else on the window, which might come as the next window. So having that distinction, even while building, is crucial. The next one is images. With images, there's an image module, which allows you to load and save images in a lot of formats. A trick that I use personally, because Pygame is not that efficient for 3D games, I download a lot of GIFs, like you call it GIFs, and then use that as an input, like an image. So it gives you the like for the user, it is a 3D feel, but it is actually not a lot of coding on your end. So that is like a smarter way of tweaking it a bit. The next is surface objects. So images are loaded into surface objects, and which can be manipulated and displayed in multiple ways. So again, based on the game application you have, use different tweaks and tricks so that you incorporate a bit of 3D, because that becomes more engaging for the user, and then add in your images. A few of the advanced techniques that you can do with Pygame. One is handling user input, which is like the keyboard, the mouse, the gamepad. So you can also add in more features like if you scroll twice, maybe the player should jump, or if you press down your gamepad with one finger, what should happen with two fingers, what should happen. Especially like when you're trying to make your character jump, it should have a natural feel as well to it. So that helps. The next is collision detection and physics simulation. So collision detection, there are a few projects in the Pygame documentation and the community as well that you can gain a lot of knowledge about what happens with physics simulation, or what happens in case of a collision. The next is sound and music integration. I'll also be sharing a bit of code on this, and animation and sprite sheets. We'll also be talking in depth about these two things, which are more complex. So let's talk about sound and music integration. With sound effects, you want to add sound effects to enhance gameplay for feedback, like footsteps, explosion, environmental ambience. Say if it is the player is walking in a forest, you want like a mystical sound so that the player feels that the player is in like a fairyland, not a real world. Or like footsteps, explosion, those are very necessary. If it is like a fighting game or something like that, when there's an explosion, there should be a sound of an explosion. Or footsteps, if you want your player to feel if somebody else is entering the room, the footsteps help in that. The next is music, for any kind of background music to help set the tone and atmosphere of the game, and that helps in improving engagement. If we see how simple it is to actually include all of this in Pygame, this is a code sample that I built in. So you just import your Pygame. I'm adding both the things, both an explosion sound as well as a background music. And my explosion and background music, I can use any kind of a format. That is why I used 2 different formats so that you get a sense of it's not just MP3 files that you want to add. It can be a custom sound. It can be something you download, something you buy online. You can add that as well. And then you just, for example, for the explosion sound, I'm just playing it. And for a mixer, I'm adding it with a -1. So I want it like a loop. And then I stop it after the explosion sound. And then I quit my Pi game. So if you see, this is like less than 10 lines of code, and explosion background will add so much of a character to your game that it will make it more user-friendly. So do make use of explosion sounds and background music. The next one is animations and sprite sheets. So with animations, you are able to create dynamic animations for characters, objects, effects, which bring your like 2D characters to more life. Now, this is also important because if you don't want to go in the complexity of 3D modeling for your characters, but animations will help you still bring a more character to your games. And it will bring in more real world-like effect to your game. And sprite sheets. So in order to optimize any resource usage and to streamline the animation management, you can organize multiple sprite images into sprite sheets. So multiple images create a sheet, sprite images create sprite sheets, and it helps to reduce the memory footprint and improving performance. The last thing in game development is that if your game is very slow, like that's the worst thing that can happen as a game developer. So using techniques like these, like sprite sheets, help you to make your game run in the desired speed that you want it to. And this is a quick code about it. So if you see, the animation loop that I have is where I'm running everything. And the coordinates for my sprite are being appended as well. So I want it to move with a 1-1 increment so that it looks as if the character is moving, but actually on the back end, I'm just incrementing. So it's a very mathematical operation I'm doing for a very visual thing that happens later on. I have only a couple of minutes left, so I'll quickly try to talk about a few additional things about Pygame as well. One is exploring creative possibilities. So procedural content generation is a key thing. There are libraries like Perlin knows or general procedural generation algorithms to craft very unique and endless varied game capabilities. So you get a lot of integration with Pygame. You can do a lot of procedural content generation with it. The next is AI and ML integration, especially for NPCs, which are the non-playable characters. So you might have extra characters in your game. For example, if it is like a burger building game, so you are the character who's like who owns the shop, is building the burger, but you might have a cashier, which is like an algorithm-based character. So what does that cashier do? Maybe if you serve the customer, the cashier does a little dance. So how do you code that? And if you want it to be automated using AI/ML, that's again a very great possibility that you can do. The next is, it is a lot of community-driven innovation. So you leverage the Pygame community, leverage the Python community, and you will be able to do a ton of things. And believe me, when you go online to ask help, like the Python community is very helpful. Whether you think it's a simple question, a complex question, there are a lot of people who are also very deep into game development. So even a complex question will have a very quick way for you to find the answer online. And the next is with respect to accessibility and inclusivity. So talking from the perspective of how the syntax is very beginner friendly. It makes it very easy for anybody of any level of expertise in game development to come build games. And yeah, so now is the time to build games. Give it a shot. Even in an hour, you can build something like the Caterpillar game, add a bit of background noise, add something else, and make something fun today. That's all from my end. Thank you.